talking about the language of motion. First, let's start off with the first law of Newton's first law. An object at rest will stay at rest unless acted upon. For example, my tennis ball will not move, and it will stay in the same place unless I act upon it, or a force acts upon it, such as me pushing it, and it will keep rolling until it is acted upon by another force, such as friction. Let's talk a little bit about vectors. Vectors have both magnitude and direction. This vector could be represented as positive because the vector below it is going the opposite way. This vector would be negative. The one at the bottom here, since both vectors are pulling on each other and going opposite directions, you would have an answer of 0. When you have a vector in an equation, it is harder to find the answer than if you were dealing with scalars. Scalars only involve magnitude and not direction. When you have a scalar in a equation, it is easier to find the answer than if you had a vector. Distance. Let's talk a little bit about it. Distance is from one place to another. It is the quantity of that length. Let's say I have a little toy dragon here, okay? He starts at point A and he goes to point B. He has traveled from A to B. That is a distance. Distance is a scalar quantity. It only has magnitude, not direction. Okay, let's talk about position. My little dragon here is Fred, and he lives at his house. And he has a friend named Phil who lives at Phil's house. And they live 2 kilometers apart. So let's talk a little bit about position here. First, Fred, the dragon, goes for a walk to Phil's house. He has traveled exactly 2 kilometers and his position has changed from A to B. But let's say he only stopped at Phil's house quickly and started to go back. Now he walked 2 kilometers back again, and he's at his house. He's traveled a total of 4 kilometers, 2 this way and 2 that way, but his position is the exact same. It is as though he has never moved, and that is position. Some people think that position and direction are the same thing, but they aren't. For example, position can be, let's say Fred goes from the bakery to Fred's house, and his position changed from A to B, but the distance was 2 kilometers. But let's say another thing happened. Fred went from the bakery to Fred's house and back to the bakery again. His position is still the same as it was, because he went from A to B and back to A. So his position is A, but his distance was 2 kilometers home and 2 kilometers back to the bakery, meaning he walked 4 kilometers. His distance was 4 kilometers, but his position is the same. Position is a vector because it describes a specific place relative to a reference place. Let's talk a little bit about time. Time describes at which an event takes place. Initial time is when an event takes place, and final time is when the event finishes. In between that is called a time interval. Time is a scalar quantity. It only includes magnitude, not direction. Let's talk a little bit about displacement now. Displacement is when an object's position changes from one point to another, and it describes that change. Displacement is equal to the final displacement, let's say Phil's house, minus the initial displacement? Fred's house. Let's find displacement now. Fred's house equals 0, and Phil's house, since it is 2 kilometers away, equals 2. To find the displacement, we start with our final displacement minus initial displacement. So we have 2 minus 0. His displacement he has traveled is 2. 2 minus 0 equals 2. Let's talk a little bit about time and time intervals. First, Fred, the dragon, is at the bakery, and it takes him 5 seconds to get home. It's pretty fast. And then but then he decides to go to Phil's house, not stop, and it takes him 25 seconds to get to Phil's house. Now, we know the calculation to find time is final time minus initial time. So, our final time, which is Phil's house, it was 25 seconds. And our initial time is 5 seconds. So, our time is 25 minus 5. 25 minus 5 equals 20. It is 20 seconds. Okay, let's talk a little bit about negative and positive. First, let's use some signs so that you know which could be negative and which could be positive. West is negative. East is positive. North is positive. South is negative. Up is positive. Down is negative. And you might find some of these in equations. So let's do a couple